Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help ISU actuary. Here's the problem for today for exam MFE. This is Spring 2007 Society of Actuaries course MFE examination, problem number 5. For a European call option on a stock within the Black-Scholes framework, you are given the stock price is $85. The strike price of the option is $80. The call option will expire in 1 year. The continuously compounded risk-free interest rate is 5.5%. Sigma, the volatility of the stock, of the underlying stock, is it's really the standard deviation of the continuously compounded rate of random rate of return on the underlying stock is 50%. The stock pays no dividends. Calculate the volatility of this call option. So you actually need to know that the volatility of the option is the volatility of the underlying stock times the absolute value of the option elasticity. And the option elasticity is the price of the stock times the option delta divided by the price of the call. And delta is equal to e to the minus delta t times n of d1, which refers to the notation of the Black-Scholes formula, where you just see here the Black-Scholes formula for the price of a call in the Black-Scholes framework. And you can memorize this formula by noticing that if you just kind of blindly took the partial derivative with respect to s, you would get e to the minus delta t times n of d1. Now, of course, d1 and d2 are also functions of s, so if you wanted to take that derivative seriously, you'd have to do a lot of work to prove this. Well, that proof is not really on the test, but you can find it in my study manual. And you just need to know this, that delta is equal to, delta of a call is equal to e to the minus delta t times n of d1. So in this context, that's the same as s times delta minus k e to the minus rt n of d2. And we're looking again for option elasticity in order to plug it into that formula for the volatility of the option. So we plug in the formula for the price of a call in the denominator. Divide the top and bottom by s times delta, and we get 1 over 1 minus k e to the minus rt n of d2 divided by s times delta. Well, but again, delta is e to the minus delta t times n of d1, so we get what you see here, 1 over 1 minus k e to the minus rt n of d2 divided by s e to the minus delta t times n of d1. Well, given that s is 85, k is 80, delta is 0, r is 0.055, t is 1, sigma is 0.50. So based on this, d1 is equal to natural logarithm of the prepaid forward or ex-dividend price of the stock divided by present value of exercise price plus 1/2 sigma squared t divided by sigma squared of t. So we plug in all these numbers and we get approximately 0.48, and d2 is d1 minus sigma squared of t. Or you can also remember that d2 has the same formula as d1, except that instead of adding 1/2 sigma squared t, you subtract 1/2 sigma squared t in the numerator. But we can plug in the numbers that we have. That comes out to be negative 0.02. from the table the cumulative distribution function of the standard normal distribution at 0.48 is 0.6844, and n of minus 0.02 is 0.4920. So based on this, we get this X dividend or prepaid forward price of the stock times n of D1 to be 85 times e to the 0 times 0.6844 or 58.174 approximately. And then the present value of exercise price times n of D2 is approximately 80 times e to the minus 0.055. Remember, it's 1 year till expiration, so we just use the risk-free rate in here. Continuous compounded, of course. That's what's a standard assumption on this test. Times 0.4920, and that comes out to be 32.2537. So that the elasticity that we're looking for is 1 over 1 minus 32.2537 divided by 58.174, and comes out to be 2.78. So that the volatility of the option is 0.50, the volatility of the stock, times 2.78 that we just calculated, and approximately 1.39, which is answer D. It makes sense, by the way, because generally call option is a form of a leverage bet on the underlying stock, so it has to be riskier. And as you see, volatility is much higher. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.